Welcome, everyone, to this new episode of CCIR Student Spotlight. With me today is Aleksander Zarebinski, a Year 12 student at Dulwich College in the UK. And during his time at CCIR, Aleksander took the Regenerative neurobiology course with Dr. Bart Newhouse. And today, Alex is here just to share a little bit about his experience at CCIR, his project, and share a little bit about his thoughts. So first off, welcome, Alex.
Welcome. Hello. It is very nice to be here. I am really honored to have been chosen as one of the Spotlight Scholars. It is really a great honor for me.
Yeah, thank you so much, Aleksander, for taking your time today. So to begin, could you just tell us a little bit more about yourself and where you come from, and maybe give us a little bit background of how you came to choose the Regenerative Neurobiology course?
When it comes to who I am, I come from a small border town in Poland. It is called Przemyśl. It borders Ukraine. When the war happened, almost 2 million refugees crossed through this town, so it was quite lively at this point. It quieted down quite a bit from the start of the war. Right now, due to the generosity of Rafa Brzoska Foundation, I was able to move to the UK in November. I was able to start studying at Dulwich College in England, in London, there as a year 12 student, doing A-levels in biology, chemistry, and mathematics. As for why I chose regenerative biology, I strive to be a neurosurgeon in my future, but also I want to push the medical field as far as it can go in the span of my lifetime. And regenerative neurobiology, I think that it is the field that will progress the furthest, and the field that I can help by, and is most closely connected to the field of my hopefully future work, and where the most significant progress can be made and can be utilized in neurosurgery operations. So, like I said, in addition to being a neurosurgeon, I would love to be a neurobiology scientist. So that is something that thrills me. That is something that I hear the calling for in my life, and that is something that I want to do and help people around me.
Excellent. So tell us a little bit more for those of us who aren't as familiar with what regenerative neurobiology really is. Could you give a quick sort of elevator pitch of what this emerging field is about?
Well, when it comes to regenerative neurobiology, let's say your arm gets chopped off. How can you reattach it? How can you heal it back on? Those are the problems that we're facing in the medical field, and those are the problems that need to get solved as quickly as possible. Because, for example, as of this point, when it comes to like spinal fractures, it is very, very hard to deal with those, because if the spinal cord gets severed, the way the neurons grow out, they basically, how can I say it? They clog up all the space with scarring tissue, and there is no way for the signal to go from the top to the bottom. So that is something we have to work on, so that people after like lacerations of the spinal cord will be able to, for example, walk again. That is really something that needs to get worked on, and that is something that this field is striving to find out how to do that.
That's fantastic. So let's maybe begin by talking a little bit about what the first half of the course of exploring this new sort of field of research was like, because I imagine you only over time began to develop your final project. So tell me about sort of the exploration stage early on with when Dr. Bart was sort of walking you through this field.
Well, when it comes to the lectures that were in the first half of the course, I found them very interesting. They were packed full of information, but that information was very easy to digest. It was sort of like getting, walked across the street by a big person, right? That holds your hand and does not let the cars hit you. It was like having a clear path like in front of you, and it was very easy to learn all this complicated information because it was delivered in such a way that it was very easy to understand. And when it comes to the topics that were covered, I think for a person that has a genuine interest in regenerative neurobiology or basically any neuroscience at all, it was it must have been very interesting. It was certainly very interesting for me because the topics that were covered, some of them opened my eyes, some of them expanded on the knowledge I already had. Some of them served as a recap to things that I already know, but each and every lecture was very helpful in establishing some new informations or correcting some things which I believed were wrong thing, right? So it was very helpful. It was very nice. It was a very good experience for any person that really strives to find themselves in the field of neuroscience. So if anyone would be keen on replicating those experiences that I had myself, you should definitely go for it because it definitely helped me, and I suppose it will help you.
Yeah, hopefully. So at this stage, I think we should talk a little bit about your own project. So to begin with, why don't you share the title of your final project for this course?
So my research project was named Introduction to Gene Therapy and the Use of AAV Viral Vectors in the Treatment of Monogenic Eye Disorders. Why was it titled this way and not any other way? First of all, my goal with this project was to once again replicate what this particular course has done for me. So it gave me a grounds up knowledge and then focused on specific cases of application. So that it gave me different points of interest that I could then develop even more. So I wanted to replicate this this experience. So what I did is I wrote a very introductory text, which then delved into significant detail, but on a very specific, very tailored, specific group of diseases and the solution to them when it comes to regenerative neurobiology, right? So what I strive to do is for a person that reads this, it can be a person that is already into neurobiology and they read it so that they can extract some information about the specific case. It can be a person without any understanding at all when it comes to neurobiology, and they can sit down, read through the text, and they can get the same information as the person that already knows something and wants to expand it. What I wanted to do is basically make an introduction for people into the beautiful field of neurobiology that I think is very innovative, and everyone should at least know about it, or at least know the basics of it.
To this end, why don't you share a little bit about what, because I have no clue what ACC or a monogenic eye disease, is that the right?
AAVs, adeno-associated viral vectors.
Yeah. So why don't you just give a layperson pitch of what exactly your the topic you're introducing is?
Basically, what I'm introducing is first and foremost gene therapy. What is gene therapy? You scientifically engineer a virus that can deliver its genome to a cell, but that genome is not malicious. It is, in fact, another part that is a scientifically engineered coding sequence that, when injected into a cell, can repair the damaged gene that was in the human's body in the first place. So what it does is basically an adeno-associated viral vector is one of the most common ones because it is the capsid is relatively small. It is relatively easy to engineer compared to other viral vectors. But the limitation is that it can only, because of its small size, It can, it's a good penetrator. It works quite well, but due to the same fact, because of its small size, it can't fit a lot of information. So it's like the two faces of the same coin. When it comes to the field of regenerative neurobiology, what we strive to do is use those viral vectors in order to heal neurodegenerative disorders, basically any genetic disorders that occurs in the human body. We strive to heal it, right? So I may stray from the path, but for example, most people probably heard of like Huntington's disease, of many different diseases like hemophilia, and for example, early onset cataracts. I'm not talking about like normal cataracts, but early onset cataracts, which appears in people that are still teenagers and kids, right? Those are genetic disorders that are slowly but surely becoming curable through gene therapy that is more and more developed and more tested. And maybe someday in the near future, even maybe one of the viewers that will be viewing this program will get a treatment for their genetic disorder. You never know.
Okay, so could you tell us a little bit more then about the specific disease that you ended up dealing with in your research paper?
So it was retinitis pigmentosa, and when it comes to that disease, pigment starts appearing in the retina of the eye, which shouldn't really appear. So it causes worsening of vision at night. Then people start to experience tunnel vision that is more and more severe, and because of the dying photoreceptors, when untreated, leads to a complete loss of sight.
And you mentioned earlier how most people, when they think of regenerative neurobiology, might track towards something like Huntington's, something a bit more familiar. Why and how did you end up choosing this particular disease to work with?
Well, I think it was an easy choice because there has been so much data on this particular disease that I chose this specifically because when it comes to gene therapy, there have been very many papers that have been conducted on this disease, and there have been already therapies that are working and that can be administered to experimental patients. So I think that when it comes to this particular ailment, people that read the article will be able to then go on and collect further information if they're very interested in this particular field, right? And like I said, the point of my paper was to introduce as many people as possible to this field, because I think that this is going to be the future of medicine.
And when we say the future of medicine, because I have very, very little background on any of this, how close are we to clinical applications of these sorts of regenerative neurobiological gene therapies?
It depends on which field are we talking about. Are we talking about like serious like normal gene therapy, or are we talking about regenerative neurobiology? Because I think that gene therapy is at the moment at the stage of like experimental medicine and clinical trials. So I think that we'll be able to see it in maybe 25-30 years, but when in conventional hospitals, right? I mean, like widespread use, when it comes to like specified clinical use, maybe 10-15 years. But when it comes to regenerative neurobiology, I think we'll have to wait a little bit more for great success in clinical trials. So I think 30 years for the clinical trials, and then I believe next add 10 years to that for widespread use.
Yeah, that's great news for someone who is exploring a career in the field. So there's plenty of work to
Most
do. So I also want to ask a little bit more about, you had mentioned that you had come into the program already with certain inclinations, a sense of a vocation with respect to neuroscience in particular and how it relates to medicine. I wonder if the course had at all shaped or furthered or enriched that sense of vocation, whether or not it's sort of changed your understanding of what you want to do in the future.
Well, most definitely, it helped me specialize myself even more because at the time of when I started doing the course, I mainly was focusing on becoming a neurosurgeon, which I still am. Don't get me wrong. This is still my lifelong dream, which I was pursuing since 6 years old when I came to a hospital and asked, what is the hardest job here? And they said, a surgeon. What kind of surgeon? Neurosurgeon. Well, as you probably can tell, I like to challenge myself. So from that point onwards, I want to be a neurosurgeon. But that's beside the point. I also wanted to contribute to medicine because I thought long term, well, I can save this many people as a neurosurgeon, but my life is only this long. So what can I do to leave a print on this world so that I can continue helping people even after I'm long gone? So what I figured is I want to become a scientist in the field that is the closest related to the job I'm going to work at, right? Or at least I want to work at. So I wanted to contribute to neuroscientific research. And this course has helped me greatly when it comes to focusing my attention on a number of specific issues. When it comes to regenerative neurobiology, I think that is the thing I want to do, and I want to help people with. And I think that the course helped me, decide which particular field of the vast, world of neuroscience that is constantly broadening its shores. I want to focus on.
Excellent. So by way of wrapping up, I have sort of two more questions for you. One
is, sure, go ahead.
Want to learn a little bit more about your working experience with Dr. Bart Neuhauser, and we also probably shouldn't forget your TA, who you might also mention in response to this question as well. What was it like working with a neuroscientist at Cambridge, or how has that helped this sort of mentorship dimension of the entire experience? How has that helped either in shaping your research paper or in your understanding of the field in general?
I can't say that the work has been, completely flawless because unfortunately, I was unable to experience it in its full potential due to the fact that, like I said, I was moving countries and whole education systems. So I had to take on lots of extra work in order to catch up on GCSEs and basically catch up on the 2 months that have just flown by me. Because I was then still in Poland because of the visa procedures were taking so long. But despite all that, I think that it was extremely worth it to partake in these kind of lectures, even though I could not extract their full potential due to the unforeseen circumstances. Plus, I also dropped my laptop, so I shattered my HDD and I lost all my work 3 weeks before the deadline. So I had to scramble, and it was tough. But I managed to redo the project, and everything turned out well in the end. Also, I think that the way lectures were structured it was very similar, at least in my opinion, to lectures in a university, where the mentor has a very close relation to his pupils. It was very nice. It was very engaging. Both Dr. Bart and Dr. Elisa were incredibly helpful with every issue. They answered each and every one of our questions. It was very nice. It was a very nice experience, and I would recommend, if any of the viewers are able to, please go ahead, pursue being able to get into the CCIR's Future Scholar program. It is really worth it. It is not only worth your time, but it is worth your future.
Yeah. That's great to hear. So by way of wrapping up, I want to just ask one last question about it's the question I typically ask students as I wrap up these interviews, which is, research takes a long time. You have to sink a lot of effort into it. It's very challenging at moments, perhaps when you drop your laptop, quite painful even. What would you say to a student who is, let's say, daunted by the prospects of the whole experience? Can you say a little bit more about why doing something like an intensive 13-week course on regenerative neurobiology, all the while moving countries, could be worth it?
Well, from my perspective, it is worth it because every investment in yourself will be worth it in the end, no matter how tough it is, as long as you manage to push through it and not get harmed in the process, because overexerting yourself is a bad thing. I have experienced it. It is not the situation you want to be in. But you have to find your space in that blurry line in between overexerting yourself and working at your full potential. Because if you don't, if you don't find your full potential, you will never be. You will never know how great you can be. And every person is great at the end of the day, because we are all humans. We are all the same. So you just have to find the golden balance between work and normal life. And when it comes to world being the world, things don't always go the way the way you want them to go. And in my particular case, is basically all the time that dead things haunt me. My laptop dropping, I don't know, the cabinet searching and hunting for my toe to stop, right? There's just a lot of things that will not go the way you planned them to go, and that's okay. Everyone is imperfect. Everyone can make mistakes. The only difference between failing and research is that, as Edison said, I didn't find 1,000 ways I didn't fail 1,000 times. I just found 1,000 things that don't work. And science is a grueling work, and you just have to pour time and time and time. But at the end of the day, you'll come out smarter and wiser than you came in. Science is very humbling, because at the end you don't know anything. You're like a baby thrown into the ocean. But being that baby, when you have someone competent guide you through the depths of it, you'll swim in no time, and probably one day even soar through the sky. There is no limit when it comes to science, and that is beautiful, because every single day researchers find things that people the day before even minutes before the discovery, didn't know that they existed, right? It is beautiful. It is honestly beautiful. So my advice to you, just power through the difficulties, but be mindful of your own health, and be mindful of what you can do, because sometimes it is just more worth it to let things go instead of holding them and letting them drag you. As for this course, I think that even though it is work intensive, I think that the mentors are very, very, very competent, and they will not let you overexert yourself. So, trust them with every fiber of their body. They know what they're doing. And at the end of the day, I believe that you will achieve what you want to achieve with this course.
Excellent. Honestly, Alexander, I couldn't have hoped for a better answer there. That was really quite beautifully articulated and almost, I dare say, quite moving. So with that, that's a beautiful note to end this interview on. So thank you so much, Alexander, for taking your time today. It was a pleasure chatting with you, and I wish you all the best luck in your future endeavors. And I hope that as a neurosurgeon, researcher, scientist, you can achieve your full potential and actually live up to the dreams that you have.
Thank you once again, and I wish you all the best. Also, may the power of science be with you.
All right, excellent. Thank you.